Hello, welcome back. The title of this lesson is called Constant of Proportionality Word Problems. So here we're going to read a problem, we're going to use ratio and proportion to solve the problem, and then we're going to calculate this quantity known as the constant of proportionality. Honestly, it's much easier if we just tackle our first problem to explain what's going on rather than just talk endlessly about it. So let's dive into our first problem. It says Regina can travel 180 miles in her car on 6 gallons of gas. How far can she travel with 5 gallons? Second question, what is the constant of proportionality in this case? So let's take a look at just the first couple of sentences here. So we know we can go 180 miles on 6 gallons of gas. So let's think about it for a second. If you can go 180 miles on 6 gallons of gas, the question is saying how far can you travel on 5 gallons of gas? Well, 5 is less than 6. So if we know we can go 180 miles on 6 gallons, then if I only put 5 gallons in there, I know I must be going less than 180 miles. I can't go as far because it takes 6 gallons of gas to go that far. So how do I set this thing up? I set up a proportion, which is two ratios that are equal to each other. I just read the problem out. It says I'm going 180, and this is miles, per how many gallons can I do that with? 6 gallons. So if I put the units, it would be 180 miles for every 6 gallons. This forms a ratio, so I'm writing it as a fraction. And this ratio of going 180 miles for every 6 gallons has to be equal to a new ratio where I can go an unknown X amount of miles only on 5 gallons of gas. So make sure you understand why we set it up this way. Basically, the problem is going to give you the core ratio of what you're trying to work with. In this case, it's miles traveled, and that is tied to gallons of gas it takes to go. So that forms a ratio, right? And that ratio is written here, 180 miles for every 6 gallons of gas. Now the other ratio is I'm going on 5 gallons of gas, how many miles can I go? And this ratio here is going to be exactly, when I divide them, exactly the same, because the engine can only travel it travels on gas. However much you put in there, it's going to go, if you put a little more gas, it'll go farther. If you put a little less gas, it'll go a shorter distance. But the ratio of miles traveled to gallons of gas is always the same because the engine is just taking the gas and turning it into miles, right? So this ratio has to be the same as this one. Notice it's miles per gallon. Miles per gallon. So when you set the ratios up and make them equal, you have to have the same units on the top and the same units on the bottom so that the ratios really are equal. So now all we have to do is solve this equation for x, and we've done this kind of thing before. Let's rewrite it. 180 over 6 equals x over 5. We want to get x by itself. We have a denominator here of 5. To clear that denominator, we multiply the right-hand side by 5, and if we do it over there, we have to multiply the left-hand side by 5 as well. Now we know in our mind that this 5 is really 5 over 1, so we can cross-cancel, since these are multiplied, we can cross-cancel these 5s here. On the right-hand side, when we cross-cancel them, we're just going to be left with an x. And here, again, you can envision a 5 over 1 here, and when you multiply 5 times 180, you're going to get 900. If you want to do that off to the side, 180 times 5, you get a 0. 8 times 5 is 40. And then 5 plus 4 is 9. So this becomes 900. And on the bottom, it's a 6. Because it's 5 over 1, multiply the numerators. 6 times 1, invisible 1 here, is 6 on the bottom. All right. Now, what is 900 divided by 6? You can run that through a calculator, or you could do it off to the side. It goes 1 time, a remainder left over of 3. Drag the next one down. 6 times 5 is 30. Get a 0. Grab this next 0 here. And then, of course, 6 times 0 is 0. And you get a remainder of 0. So 6 times 150 is 900. And if you want to absolutely check it, you can multiply these. 150 times 6. You get a 0. This is a 30. And then 6 plus 3 is 9. So it does come out to 900. So all of that to say, when you take 900 divided by 6, you get 150, and that's equal to x. So what does this mean? X is equal to 150 miles, right? Let's see if it makes sense. If we know that on 6 gallons of gas in the tank, we can actually go a distance of 180 miles. Then on a lesser amount of fuel, we should go a shorter distance. And in fact, we do go 150 miles, which is shorter than 180. So our answer passes the smell test, right? Now we want to turn our attention to the second part of the problem. It says, what is the constant of proportionality? That is a fancy way of saying, tell me the ratio, the smallest ratio between the two things that this problem involves. This problem involves miles traveled per, or related to, the amount of gallons of gas. Those are the only two quantities in here, miles traveled, gallons of gas. So if we divide those, we're going to get a ratio. That's what ratio is when you divide them, right? Put them in a fraction, that's division. And try to simplify it as much as possible. That thing is called a constant of proportionality because it is the same ratio between miles and gallons. No matter how many miles and gallons, no matter how many gallons of gas I put in the car, I'm going to go a different distance, but that ratio of miles to gallons will always be the same. If I put more gas in, I go farther, but the ratio between miles to gallons is always the same. Let's see if that is true. All right, in this problem, I know that I've calculated that I went 150 miles, right? So I can make a ratio of 150 miles to 5 gallons because that's how far I went on 5 gallons, right? So notice I have units here, and this is division, 150 divided by 5. All right, 15 divided by 5 is 3, so 150 divided by 5 must be 30. And the units, you can't really cancel anything, so it's just miles per gallon. What it means is my car's efficiency is 30 miles per gallon. That means on 1 gallon of gas, I can travel 30 miles. And I got this ratio from knowing how far I went, 150 miles on 5 gallons. Now, let's turn our attention back to the original problem statement. Original problem statement said I can go 180 miles on 6 gallons. It's right here in our proportion, 180 miles, 6 gallons. So let's calculate it using that, 180 miles per, or related to, 6 gallons. Now, 18 divided by 6 is 3, so 180 divided by 6 must be 30. You see what I mean? I went a little bit farther here because I put more gas in the tank. And so the numbers are different, but the ratio between them two, when you divide them, still works out to 30 miles traveled per a single gallon of gas. Here, I put less gas in the tank and I went a shorter distance, but when I divide the ratio and find the ratio, I still find that this engine can take me 30 miles on a single gallon of gas, 30 miles per gallon. So we call it a constant of proportionality whenever you have two quantities that are kind of related to each other, and no matter what the numbers are, then when you take that simplified ratio, you get the same ratio back, in this case 30 miles per gallon. We call it a constant of proportionality because the number is constant. It doesn't change. 30 miles per gallon is the same no matter how much gas I put in the tank and how far the distance. I could put 1,000 gallons in the tank if it could hold it, and I would go a huge distance. But the ratio of miles to gallons, even in that case, would still be 30 miles to gallon because the tank and the car can only go, it only works on a mechanical system. It's only going to go farther by the same amount, by the same ratio, depending on what you put in. All right, let's take a look at problem number 2. This involves a scale and a map. It says, a scale on a map that at a distance of 2 inches on the map represents a distance in 5 miles in reality. If the distance between the two cities is 15 miles in reality, what is the distance between the two cities on the map? What is the constant of proportionality in this case? So you've all seen a map, right? When you have a map, it's a small picture of the real world. So 1 centimeter or 1 inch on the map might represent many, many miles or many kilometers in reality, right? And that forms a relationship between distance on the map to distance in real life. And if I go farther on the map, it'll be farther in real life. If I go shorter on the map, it'll be shorter in real life. But the ratio between them, the constant of proportionality, will always be the same because the scale, the relationship between the map and real life, it's always the same ratio. So we want to figure out that ratio as part of the problem as well. So the problem says that I can go a distance of 2 inches on that map, which is related to 5 miles in reality. 2 inches to 5 miles in reality, right? If the distance between two cities is 15 miles in reality, reality goes down here, how far on the map is that distance? This is the proportion, the two ratios that must be equal in this guy. because it's 2 inches on the map to 5 miles in reality. How far on the map would 15 miles in reality be? Notice that the units are the same. Inches on the map are on the top, and miles in reality are down here. So let's solve this. 2/5 x over 15. So I want to get x by itself. I'm going to multiply by 15. So I'll multiply by 15. And what do I actually get? Here, the 15s cancel, and here I have a 15 and a 5. I can simplify this. Actually, let's just do it a different way. 2 times 15 is 30, and then I'll have a 5 on the bottom. So multiply the tops. 5 times the invisible 1 here is 5, and what I'll get is 30 divided by 5 is 6. Now, what unit is it here? So it's 2 inches and 2 in inches on the top, so inches. So what it basically is, what we have found is that if for every 2 inches on the map equals 5 miles in reality, then 6 inches on the map must be 15 miles in reality. It makes sense, because if you go a larger distance in reality, then it must be a bigger amount of inches, and it is 6 inches. So the constant of proportionality in this case will just be the relationship between inches on the map to miles in reality. Let's see what that constant of proportionality actually is. All right, so for our problem, we know that we traveled 6 inches on the map, right? And that's related to, in real life, 15 miles. So you put your little units in there, and you know that 6 over 15 is division, right? But this is a fraction. We can divide top and bottom and simplify this fraction, right? So what do we have here? 6 divided by 3 is 2, and 15 divided by 3 is 5. So 2/5, right? And the units are still here, inches per mile. So what does this mean? This ratio is the simplified ratio between the map distance and the distance in real life. 2/5 of an inch is smaller than an inch, but that's how far you go on the map in inches for every 1 mile in the outside world. So this is the constant of proportionality. Now, what if we do the same thing with the original information, which the problem said? It says right here, 2 inches for 5 miles in reality. So we can actually read this one straight out. 2/5 inches, or I should say 2 inches per mile, right? 2 inches for every 5 miles, sorry. And when we can't really do much more with this fraction other than just write it down, 2/5 inches per mile. So it's the same ratio, and it comes straight out of the problem in this particular case. We know the map scale, 2 inches per every 5 miles. When you divide those numbers, it's 2/5 of an inch for every mile in the outside world. So we get the same number, we get the same ratio, the same constant of proportionality, because, as I said, the scale between the map and real life is fixed. It's locked. It doesn't change. So no matter what numbers you put in, you should get the same constant of proportionality out. All right, let's take a look at problem number 2. It says commercial time over the radio can be purchased in increments of $100 for every 30 seconds. How much commercial time can be purchased for $300? What is the constant of proportionality in this case? So, same sort of thing. We're talking about commercial time in seconds and dollars of cost there. So, for 30 seconds, it cost how much money? You just write it down, $100. So it's 30 seconds for every $100. And then we want to figure out how much is it going to cost, or how much time can we purchase for $300? That's what it says here. How much commercial time can be purchased for $300? So 30 seconds, this is an unknown number amount of seconds, $100, $300. The same positions have to be in the ratios because they have to be equal to each other. So let's solve this guy. 30 over 100 equals x over 300. So I'm going to multiply here to clear this denominator by 300. I'll multiply this by 300. Now what do? We have a cancellation right here. And what can we do? Let me rewrite this. 30 over 100 times 300. And this is just equal to x. Now you see what we have. We have on the top and bottom, we can divide by 100. 100 divided by 100 is 1. 300 divided by 100 is 3. We just cross simplify here. Now multiply. 3 times 30 is 90. And that's equal to x. So x is equal to 90. 90 what? What are we calculating? This is the top unit, which is seconds. 30 seconds, 90 seconds. So that's how much you can purchase for $300. Now, does it make sense? We know that for $100, we can buy 30 seconds. If we triple our budget to $300, we must triple the amount of time in commercial space that we can buy, which triple of 30 is 90. So that makes sense. Now let's find this constant of proportionality. Well, from the problem statement, we can purchase 30 seconds for every $100. Right? Now, if we simplify this, we can divide by 10 and divide by 10, or just strike the zeros, and what we're going to get is 3/10 and seconds per dollar. This is the simplified ratio called the constant of proportionality. 3/10 of a second is smaller than 1 second, but that is the amount of seconds you can purchase for $1. This is the ratio of how much seconds I can buy per dollar of airtime. See, the original problem was 30 seconds for every $100. This is the simplified ratio. We call it the constant of proportionality, less than 1 second, 3/10 of a second for every $1 whole dollar. Now let's calculate the same thing using our answer. We had 90 seconds. How much money did we spend on 90 seconds? We spent $300. Right? What is 90 divided by 300? Well, we can simplify that ratio, right? We can say 90, 300. We can divide by 3, right? We can divide by 3. Actually, we can divide by 30. We can divide by 30. 90 divided by 30 is 3, and 300 divided by 30 is what? 10. So we still get 3/10, and the same units apply, seconds per dollar. So we get the same answer. And the constant of proportionality for these problems should always be the same. No matter what information you put in, you should get the same amount of seconds of airtime per dollar that you spend, because it's all a scale that just goes up, and however much more money you spend, you get that much more airtime. But the simplified ratio, the constant of proportionality, is 3/10. You should get the same number every way you calculate it. All right, I think we have one more problem. Water is evaporating from a pool at a rate of 2 centimeters every 8 days. How many days will it take for 7 centimeters to evaporate from the pool, and what is the constant of proportionality? So let's write down our ratio. 2 centimeters for every 8 days. So 8 days for every 2 centimeters. And it says, how many days will it take for 7 centimeters to evaporate? So we write it like this. If it takes 8 days for every 2 centimeters to evaporate, how many days will it take for 7 centimeters to evaporate? So the same units have to be top and bottom. So let's solve. 8 over 2, x over 7. We want to get rid of the 7, so we multiply by 7. And on the right-hand side, these will cancel. And so what you're going to have on the right-hand side is x, and then 8 times 7 is 56, and you'll divide that by 2. 56 divided by 2 is 28. So 28 what? What are we talking about? This is 8 days on the top, so this is days over here, days. So does it make sense? If it takes 8 days for 2 centimeters to evaporate, then if 7 centimeters actually evaporated, it must have been a longer amount of time, 28 days. Now let's calculate this constant of proportionality. Right? We say that it takes 28 days for 7 centimeters to evaporate. So we divide, 28 divided by 7 is 4 days per centimeters. This is the constant of proportionality, right? Because we know it takes 28 days for every 7 centimeters. The simplified form of this is 4 days for every 1 centimeter. Now let's calculate the same thing using the original data we have. We know 8 days. For 8 days of evaporation, you only get 2 centimeters of water evaporated. You divide these, you get 4, again, days per centimeter. Just like this. So again, you should get the same constant of proportionality. So this lesson was trying to really get you comfortable and familiar with constants of proportionality and ratio and proportion problems. You really can't get a handle on how to do these kinds of things unless you see them done and practice them yourself. The idea is that when you have something that is 2 things that are locked together in a fundamental ratio that doesn't change, then you can scale that and calculate kind of the new value depending on what you change down the road. When you have a map and you measure 1 inch on the map, and that's so many miles in reality, if you then go 5 inches on the map, it's going to be 5 times bigger in reality in terms of miles. But that fundamental ratio, the fundamental constant of proportionality, when you divide distance in real life divided by distance on the map, whatever pairs of numbers you pick, you're always going to get the same constant of proportionality because it's a fundamental relationship that's locked in place. That's the point of this lesson. So go through these yourself, make sure you understand, and then follow me on to the next lesson. We'll continue building your skills.